Hey there, welcome back to another video from the Math Doc. We're continuing with problems that have to do with linear equations. So linear equations, as a reminder, are equations that have a variable that shows up in with one power. So just x or whatever the variable is, we'll only see terms that include x or constants, where constants are just numbers like 3 or 7 and so on. In this video, we will focus on linear equation and triangle angle problems. In general, the whole set of videos that will come out in the next few days will focus on different geometric subjects where we can practice linear equations, and you'll see a lot of the problems you get at school or in tests have to do with using linear equations to solve all sorts of geometric problems. And we'll start off with triangle angle problems. In the description below, there's a whole bunch of links to the videos that provide the background for linear equations and how we solve them. So take a look at those if you haven't. If you're new to this channel, please subscribe and let's get going. So when we talk about triangle angle problems, usually what we're trying to do is figure out the values of the various angles. So we can have an angle X, an angle Y, an angle Z, and the goal is usually to figure out what the values or what the measures of the angles are, right? And the measures are we usually measure that in degrees. And what we do know about triangles, and this is only for triangles, we know that the sum of all measures of the angles of a triangle, so the sum is equal exactly to 180 degrees. And that is the important rule here. So here we have x plus y plus z equals 180. And that is true for every triangle. It is the only value that the sum of measures can take. And that is usually the tool we use in order to solve these problems. So let's get started with our first problem, and hopefully this will illustrate what I mean. So let's look at a problem. Let's look at a right-angled triangle. Okay, so when we say right angle, we mean this angle that has two perpendicular sides. That's a right angle. And the value, the measured value of a right angle, put in a little arrow, is exactly 90 degrees. So every right angle is exactly 90 degrees. Now we have two other angles here, and I'm going to call this smaller one x. So the measure of this angle is x degrees, and I can put a little degree sign there, but I don't have to. And let's say the measure of this angle here is 2 times x degrees. So we have three angles. We have the 90 degrees, we have x degrees, and we have 2 times x degrees. And those are our three angles. Now what we know about this is that the sum of all three, right, equals 180. So we can write this out as a mathematical expression. So 180 is equal to the sum of the three angles, 90 plus x, that's the first angle here, plus 2x, right? So we wrote that out. Now we can go ahead and use our various equality properties and other properties of arithmetic in order to solve for x. So what we want to know is our goal, right, is solve for x and know all angle measures, right? Okay, so we have this equation here. Now let's take the next step, which is to solve it for x. So what is the first step we usually use? I'll write that out right here. 1. Let's try to combine like terms. Like terms, we have two types of terms. We have variable terms and we have constant terms. So in this case, we see that our variable, we have two terms. We have x and we have 2x, and they're both on the right-hand side of the equation. So let's bring that down here and write it out again. 180 equals 90 plus. Now we don't know what x is, but we have one x here and we have two of them there. So we know that we have three x's because we can combine these like terms. So 1 plus 2 is just 3, so we have 3 x's. Okay, so we've done that first step for the variables. Now, let's try to do the same thing for the constant terms. But for the constant terms, we have a slightly more difficult problem because they are on different sides of the equation. We have one here and one here. So what we're going to do is we will use the subtraction property of equalities in order to simplify this. How do we do this? Let's write this equation out again. Well, again, all this is in the previous videos, but let's subtract 90. We take the inverse operation to the plus 90 here. Let's take minus 90 from both sides of the equation. So we have 180 minus 90, which is actually 90. And then we have 90 minus 90 here, so that gives us 0. And here we just get plus 3 times x. So 180 minus 90 gave us 90, 90 minus 90 gave us 0, and the 3x remains unchanged. So now our equation looks nicer because we've combined the like terms. On the left-hand side we have numbers, we have constants, and on the right-hand side all we have is variable terms. Because what is our next step? Our next step is that we would like to isolate our variable x completely. In order to do that, we will need now to use the inverse operation to 3 times x. We want to leave on the right-hand side just x. What is the inverse operation? The inverse operation is division, so we will use the division property of equalities. So we have 90 equals 3 times x, right? The 0 cancels. Now let's divide both sides by 3. We use the fraction symbol for the division. And now we have 90 divided by 3 on the left-hand side, which is exactly 30. And that equals 3 divided by 3. These two 3's cancel, right? We have 3/3 basically, which is a whole. So 30 equals x. So what we got is that in our triangle, we had the 90 degrees here. Now we had x here and 2x here. So if x here is 30, 2x is 60. Now we can also check our result. Let's check the result. How do we do that? We check by adding up all the angles, right? Add up all angles. Let's do that. We have 90 plus 30 plus 60, and you can check and see that that equals 180 exactly, and I will put the units here, which are degrees. So we checked our result, and it is correct. Let's look at another example. Let's draw another triangle. This time, we won't decide a priori what type of triangle it is. We will just draw a triangle, and again, we're going to have 3 angles, of course, in a triangle. And this time, we will give the measures all in terms of our variable x. So we have x plus 5 for this one, x plus 25 for this one, and this one equals x plus 30. Okay, so again, our equation is fairly simple. We know that the sum of the measures of all three angles equals 180. So we can just sum these up. We'll write 180 degrees equals, okay, the first angle is x plus 5 degrees. The second angle is x plus 30 degrees. And the third one is x plus 25 degrees. Okay, again, the first step would be to combine like terms. So let's focus on the right-hand side. We have both types of terms here. We have the variable terms and we have constant terms. We'll write it out by using the commutative law. I will move around some of these terms. So I'll write x from here plus 5. I'm going to write that all the way over there. Now I'm going to take this x and move it to here, plus x, plus 30 to here, this third x plus x here, and then this 25 degrees plus 25. So what I've done is I've switched around the different addition operations. I could get the variables on one side of this equation here and the constant terms on the other. So what do we have? We have 180 equals, we have 1, 2, 3, we have 3 x's, let's write that out, 3 times x, plus, and now we have 5, plus 30, that's 35, plus 25 is 60. So we have 180 equals 3 times x plus 60. Our next step will be to combine all the constant terms. To do that, we have to move 60 to the other side, and we do that again by using the inverse operation to plus 60. The inverse operation to plus 60 is minus 60. So we take minus 60 from both sides of the equality. So we get here on the left, we have 180 minus 60, which is 120, right? Equals, we have here 3 times x, and now our 60 minus 60 combines to 0. So we have 0 constant terms now on the right-hand side. Our last step will be to really isolate the variable completely by taking the inverse operation to 3 times, which is just divide by 3. So 3 times, the inverse operation is divide by 3. Let's use the fraction symbol. And we don't have to divide 0 by 3 because that'll stay 0. And we have 120 degrees divided by 3. That's just 40 degrees. Equals 3 divided by 3 times x. And the 3's cancel. And our result is that x equals 40 degrees. So now if we go back to our original problem, we can write 45, we can write 65, and we can write 70, right? 40 plus 5 is 45, 40 plus 25 is 65, and 40 plus 30 is 70. And you can check the result by adding these up. 65 plus 45 plus 70. 5 plus 5 is just 0 with 1 carried over. We have 1. 7 with the 6, 11, and then plus 7 is 80. So our total is 180. So this result is correct, and we solved this problem correctly. So again, if you're new, please subscribe. If you have any comments, please include those below. I'll be happy to respond. Like, and see you next time.